After waiting a long time, COVID is finally releasing its grip on our lives. This also means that all the festivals can be organized again. Unfortunately, festivals are mass producers of plastic waste. In this project, we try to find an eco-friendly, bio-based and biodegradable alternative material for a disposable poncho. Our alternative needs to have certain requirements regarding its thermal properties, water resistance and biodegradability. We analyzed three bio-based and biodegradable plastics: PLA, Solanil, and PHB with 1% PHV. Because most disposable ponchos nowadays are made of LDPE, also this plastic was analyzed as a comparison. In the second semester, we chose to further investigate the possibilities of Solanil by adding glycerol both in 4 and 10 weight% as a plasticizer to hopefully make it more suitable for a poncho. During the year, we have used many equipment to achieve our final result. For the thermal properties, we used TGA and DSC. Processing of the different materials was done mainly with the plate press. The compounds, however, were formed with an extruder and were pelletized afterwards. We also determined the flow behavior with the real meter and the mechanical properties with the tensile test. Next, because our poncho needs to be waterproof in the rain, we performed a rain test in which we held films under an ice shower for 3 minutes. To see whether the film withstood this rain, we put a piece of water-absorbent paper behind the film. One of the most important properties of our poncho is its ability to biodegrade. To investigate this, we worked together with the waste management company EcoWerf. A film of each material was put in compost for 4 weeks, both at EcoWerf and in the lab, to compare the degradability at an industrial plant and at labo scale. Both the samples at EcoWerf and in the lab were analyzed weekly to follow up the degradation. Finally, we give a quick summary of our main results. At the waterproof test, the pure materials all did relatively well. Unfortunately, the compounds didn't really meet the requirements to be called waterproof. The tensile test, however, did give the results we had hoped for. The glycerol made the Solanil more flexible and ductile. The tests for biodegradability were very interesting as well. LDPE did logically not degrade at all, but also PLA had a poor result, which was not expected, since PLA is already a commonly used biodegradable plastic on the market. The results of Solanil were very promising, and what is very relieving is that the compounds had a similar result as the pure Solanil, meaning that the glycerol did not affect the biodegradability of Solanil. Finally, the PHB with 1% PHV had a very remarkable result, as it was nearly fully degraded after 3 weeks. So, this was a brief review of our project. If you want to know and see more of our results, come visit the Poster Market and check out our demonstration.